So next, let me introduce the idea of inner products. So we have seen that the wave function psi has important interpretation in terms of the probabilistic structure of quantum mechanics. To flesh this out in more detail, we need to introduce the idea of an inner product between two different wave functions. So let psi and phi be two different wave functions. Then we define the inner product between these two guys as psi, the bracket of psi comma phi, as the integral. And here we're going to take three-dimensional space to begin with. And then take psi star, we take the first wave function and take its complex conjugate. And of course, this is going to be a function of the three spatial variable as well as time. And it'll be a function of phi. Phi is also a function of the three spatial variable and time. So this is what we mean by an inner product. So in one dimension, the inner product is going to be given by one of the obvious properties of the inner product is that if I take psi, the inner product of psi and phi, and I take the complex conjugate, then it just reverses the order of the wave functions. So what this means is that if I take both wave functions to be the same thing, then of course this is a real number. And not only that, because we know the explicit form of this inner product is, we know that psi comma psi is greater than 0 or equal to 0. And the equality holds if and only if the wave function psi is just 0. So this is the notion of inner product, and it plays a central role in quantum mechanics.